All right, right here, right now, I am going to show you how to come up with the entire equation for the parabola from two pieces of information. The first piece of information is the vertex is at -2, 0, and the directrix is at y equals 4. So we're going to take it in 3 simple steps. We're going to take number 1, take these guys and put them up visually here on the number plane. That's going to help us see what the orientation is, what the focal length is, and once we have that information, then we can decide which of the 4 standard formulas we can use to slot the information in. Now those 4 standard formulas are for change of origin, or when we translate to a different origin. As you can see, -2, 0 is not at the origin, so we're going to need this formula. Once we have all the information, we slot it into that formula, and that'll give us the entire equation for this particular parabola. So let's go to step number 1. Take these guys, put them on the number plane. So what do we have? We have the vertex at -2, 0. So let's go ahead and find that. On the x-axis, -2, 0 would be right at this point right there. So let me just mark that up. So there's our vertex. Let me just write that up. So vertex V is equal to -2 and 0. That's our first piece of information. What else do they give us? Well, the directrix is at y equals 4. So we've got the y-axis right here. And let's put that directrix in. I'm going to put it in red. So that's going to go through 4, like that. There we go, through 4. There's our directrix going across there. So we have those 2 pieces of information. Now, there's no parabola, but we do know the focal length. The focal length is the distance between the directrix and the vertex. So if that distance there, as you can see, is 4 units, so we know the focal length is 4 units, so let's write that down. So that means A equals 4. That's pretty good. Do we know where the parabola is going to go? Well, let's put in the focal point first before we put the parabola. The focal point will be 4 units, because we know A equals 4. 4 units down this way to about this point here. So the actual parabola's axis would be something along there. The axis will be going through x equals -2. And that's our focal point right here. That'll be at 4 here, another 4, it'll be -4, approximately there. So this will be our focal point right here, focal point. Let me just write it in. Focal point will be at -2 and -4. Not that we really need it, but that's our focal point. And why does it help? Well, it tells us it's inside the interior of the parabola, meaning that if that's the vertex and that's inside, it's going to have this type of orientation. It's going to be concave down like that. So let me just put it in. Concave down. So there's the vertex. There we go. So our parabola is going to look something like that, concave down. Inside is the focus. On the other side is the directrix. Now, we have a good view to the parabola. So now we can decide that it's concave down, which formula of the 4 standard formulas we can use. So it's got a negative downward look. So let me just reveal which formula we're going to need. Well, because it's concave down, not concave up, the x squared is going to be on the left-hand side, isn't it? And because it's concave down, the actual focal length will have a negative in front of it. So let me just reveal the formula here. So that's the formula we'll be using. Notice the x squared is on the left-hand side. So we've got x minus h, all squared, equals -4a y minus k. You can see the k there because the parabola is just over there. So we've got that negative thing happening. Why is it negative? Because it's concave down. All right, x squared on the left-hand side. If it was positive there, this would be concave up. So we've got the orientation, we've got the focal length. Now, all we have to, and we've got the vertex, all we have to do is take these guys, slot them into this standard format, and that'll give us the entire equation for the parabola. So let's go ahead and do that. So here we've got x minus h, so it's going to be x minus, and what's the h value? Remember, h and k are the coordinates for the vertex, and h represents the x, and k represents the y. So the vertex we have over here, so let me just put h and k here. H and k. Let's have a look in the formula. H and k right there. So we just slot them in there. So let's see what we get. We get x minus, what's our h value? H is negative 2. X negative 2 all squared equals negative 4a. Now what's our a value? Well, we know a equals 4, don't we? Like that, 4a equals 4. Y minus k. Now, what's k? K is 0. So it's just y minus 0. Okay, so that's what our formula looks like, y minus k. So let's simplify this now. We've got two negatives there. That'll turn into a plus. So that'll be x plus 2 all squared. Negative times a positive is going to be a negative, so that equals negative 16. And y minus 0, we just dropped the 0, so that's just going to be y. And that is the entire equation for this parabola right there.